Hello everyone, and welcome to my video about the DSOMM. It is a continuation of my first video about the frameworks on processes and not specific application development frameworks, but let's roll on and have a quick discussion and introduction to the DSOMM Level 1 and how to basically build the foundation for security of DevSecOps practices. So first of all, what is DSOMM? And the DSOMM, as you can see on this slide, it's basically a framework. I briefly spoke about it in a first video in this series, but it helps organizations to integrate the security into their DevOps practices, or at least it's supposed to do. And it should help organizations to, first of all, measure, have some sort of idea, as I said in the first video of this series, that frameworks help you to remove all of that complexity about thinking things through, and instead just to have a framework so someone thought it already and you can follow in their steps. But obviously you would have your own implementation and your own flavor, and with those frameworks it's quite often that you can just lawyer your way around and say that actually it's said something and something for this framework, for this step, but actually we implemented it in a something else and slightly different something way, but it's good enough for us. So because of that, we agree that we achieve that level or certain requirement was met. Anyway, what I wanted to say for this one is that we wanted, in this video, I am going to focus only on the level 1, and that it will grant us some sort of a foundation to go even further if we would follow this framework. And we will discuss in detail what are the specific steps and how you can implement it. I might create a separate video in this series, in this playlist, for some of the more specific topics for the DSOM. But for now, let's see what we can get about that framework in general. Right now, I will probably stop a little bit from the slideshow perspective, and instead I will click into the DSOM itself and how it looks like. So it is available over here on that URL, and you can see that it is represented as this circle diagram where people could click on things and say that, yeah, we implemented this or not, and then it will be highlighted as green. And the obvious idea is that you would go one by one through those circles and get as far as you can. Or maybe just say that we want to focus on level 1 only or level 2 only, and we are not really interested in those further ones, and get the foundation done first. But it is available over here, and we will get through those individual items later in the video. For now, I will continue with the presentation, if you don't mind. And basically to understand the level 1 of the DSOMM, DevSecOps Maturity Model from OWASPs. It is basically, as I said, the foundation for your security DevOps practices. And the idea is to establish that basic security posture within your workflows, and to have at least some sort of understanding and awareness of what is possible, what is your current footprint in terms of the security, and what you can improve on. With that being said, the whole DSOMM diagram, it is actually split into 5 different sections, and then there are sub-dimensions on top of that. But the main ones are the build and deployment, culture and organization, implementation, information gathering, and tests and verification finally. Each of them, they are pretty self-explanatory, I would guess, but to highlight them, the build and deployment, it's all about the builds, so how you build your application, how you deploy it, if it's in a secure way or not. And on top of that, one additional sub-dimension over there is patch management. So when there are some patch updates for your dependencies, how you manage those and what you can do about them. A quick spoiler, actually, for level 1, there is already quite an interesting requirement to have automated pull requests created for all of their minor patches or for patch releases. And for some organization, it could be a little bit harder to implement. And I might create a video specifically about this one. The next one is culture and organization. There you just focus on how your organization handles the security, what is the culture in terms of the security, and how you could learn and educate pretty much everyone what needs to be done and why that needs to be done. Next one is implementation, and this one I would guess one of the easiest to understand from the developer perspective or the point of view, because it's the most straightforward old world implementation of the security. So if your code, the application is secure enough, and if your infrastructure settings and all of your uh, services that you run, if those are secure or not. And that's the main topic for that implementation dimension. And let's go to the next one without a lot of discussions. This one is information gathering, basically how you get your logs, how you get your alerts, and how you get your metrics for the application or for the solutions that you run. And the last one, the green one, tests and verification. Once again, straightforward how you make sure that everything is tested correctly and working as expected, but with focus on security and not the actual unit test of your business logic. So here it's mostly about the security testing of your application. For level 1, it can be split a little bit different. And you can say that there are, once again, 5 of the core components of the DSOMM Level 1, and they can be mapped into those individual items. But pretty much it's about the culture, about the risk management, and other items that you can see on the screen. And probably let me quickly go into the actual what is required for each of those items, and then we can take a look at the diagram, the circle diagram of the DSOM again, and discuss what is over there. So culture and awareness at level 1, the main objective is to ensure that all team members understand their role in security and what you need to do about the culture and awareness. It's pretty much the ad hoc training for your developers, and those can be based on newsletters. So you could just send some sort of a notification that, hey, did you know that to write a secure code, you don't need to hard code all of the passwords all of the time, and maybe only half of the time. And on top of that, that when someone asks a question that, hey, can I have a security training? The correct answer from the organization perspective, from the culture and awareness sub-dimension or metric, is to say, yes, sure, what do you want to learn about this? So the organization supposedly should have a budget allocated for all of the security training specifically for the developers or other employees. For the risk management, that's the next slice of the DSOM. It's basically organization or you need to understand what is the organization security risks, what are their and what are their priorities, what are their risk appetites for your organization, and to do that, the key activities would be to identify what kind of systems do you run, what kind of data do you store, and you need to have a risk assessment done. And even better, if those risk assessments are done on a periodic basis, so not just we've done it once and never again. Uh, Next one is secure development practices. And for this one, it's, as it said in the title of this slide, pretty much just to have secure code practices implemented and introduced into your work environment. So you need to be able to, as I said in the last example, not to hard code all of the codes. You need to be able to verify that it's actually the case and to start some sort of dependency scanning for known vulnerabilities. And those mainly come from your dependencies. So you should be able to scan for the dependencies and create those automated patches, as I said, and pull requests to update all of them. Uh, and second to last is operational security. It is about how you handle your application and how do you know if everything is okay or if something goes terribly wrong right this moment, and how would you handle all of those security incidents when something goes wrong. So you need to have some sort of login mechanisms enabled. You need to be able to alert yourself and at least have some sort of playbook, so people who would handle those security incidents would know what to do, who to contact if escalation is needed, and so on and so forth. Finally, the latest one is governance, and it is actually quite often can be used as a basis for the ISO 27001 certification. So pretty much if you have your information security policy set up around the DSOMM, and it is perfectly normal and fine, you could have that policy say that in our organization, we want to achieve level 2 of the DSOM and maintain it. And here you go. Based on this policy, you can start your ISO certification. But in order to start this, you need to share a simple and start to write this simple security policy. And one of the first ones, at least that one is required for the DSOM level 1 that we are focusing on right now, is to have the backup and disaster recovery policies in place. And on top of that, it would be good to establish this initial compliance tracking. So if some of the teams or some of the applications do not have full coverage from certain policies, at least to have them noted somewhere as a gap or as a risk, and yeah, just to keep it that way. With that, let me stop the slides again and let's maybe jump into the DSOM diagram and discuss each of those items individually and how they follow those sub dimensions or the way how I structure them. I usually start from the build perspective, and the first three sections they are for the build and deployment part of the DSOM. And for the build, it's very easy. You basically need to have a defined build process. Even better if it is in a automated way. So you can click on this dialog over here, and it will show you the what is required for this item to be implemented. And pretty much if you do your builds on your local machine and then somehow send those artifacts somewhere else to be executed, it's obviously a risk because there is no reproducibility, and how it is built, it can be quite hard. And if that person who is responsible for the build somehow leaves the organization, it can lead to a whole lot of mess. So the correct solution is to have a well-defined build process, and pretty much that if you use something like GitHub Actions or Azure DevOps or Jenkins, you define your build process in a file. In a template, would it be YAML or something else? And the computer, the server should run the build, and so on. The next one is the deployment sub-dimension, and here we have two items. The first one is the deployment process. It's the same as a build, but now it is about the deployment to your environments. And the next one is to have the inventory of your components. And in this regard, it can be as simple as just a Confluence page or something like that with your core components being listed and described to a certain extent. Not necessarily that you introduce new microservices or services on a daily basis. So some sort of a manually maintained list of those components could be good for your life. Next one is a patch policy, patch management, and here one of those governance policies that are required, that I mentioned before. It is a patch policy that it is defined somewhere on your organization level, and on top of that, it is about the automated PRs for patches. So whenever your system or something finds out that there is a update for one of your dependencies, there should be a pull request created in an automatic way. If you use something like GitHub to host your code, it's very easy. So there is a depender bot. But if you use Azure DevOps, then it could be a little bit more complicated, or your local version of Bitbucket, and then you would need to introduce some sort of a tool by yourself and maintain it. And my recommendation, for example, and I will cover it in one of the next videos, would be to use Renovate for this. Next is design, and this one will fall into the uh, other section of the DSOMM already. And here we need to have this threat modeling exercise. So that would fall into the risk management from my previous slide. And basically, yeah, you get as a team together in a room, have some fun trying to discuss how would you break your system and what would be the risks about it. And you can include not only the developers, but it would be really good to include POs, PMs, and other product people or salespeople. So it can be a lot of fun, and you could be surprised, but there would be a lot of good coming from this kind of exercise and workshop. Next one is about the education and guidance, and yeah, basically you need to have those requests about the security training being approved and at least being available. And on top of that, those ad hoc trainings when something happens or when someone new joins their company, then there should be some sort of education in place. For the process, as I said, you need to have another policy defined. So for the business continuity and disaster recovery one. And once again, this can be quite simple and it's on an organization level. So so far from all of those, the automation or the development work would be required for the build, deployment, and for the automated patches only. And even this one with the asterisks in place. Uh, Next, the hardening ones, so those from the implementation part. And there are two of them. One of them is contextualized encoding. This is quite easy, and if you use, and it's could be treated as a database related one. So if you use ORMs, then you have this contextualized encoding in place already. So pretty much you do not send data without any encoding in place. And for the app hardening, it's slightly different. There is a separate path of it, and there is a OWASP application security verification standard. Uh, and basically, you need to start fulfilling requirements from this one. And I might create a separate video about this one specifically. But a quick Spoiler once again, and looking forward into that video. The level 1 and 50% of that level 1, it's pretty simple, and if you do your good development practices, then most likely you already have the whole level 1 covered by itself. Next, we have the development and source control, and the requirement here is that you use versioning. So pretty much in your source control, you can distinguish between different commits. Next, the infrastructure hardening, and once again, all of those are no-brainers. You need to have the multi-factor authentication for your admin accounts for the infrastructure code, for the infrastructure services. So if you use, for example, Azure or AWS, then it's not that you use root user for Amazon without MFA, if it's even possible right now. And instead, admin accounts should have this multi-factor authentication enabled. And on top of that, you use edge encryption in transit for your data. So from your infrastructure perspective, your application doesn't send unencrypted data back and forward. And system access control for systems, it's once again that you are not using a single simple authentication, single user, but instead that you have some sort of access control in place, and different users should have different type of authentication and potentially different permission over your system. Next section is about logging and monitoring, and here we have centralized system login. So that's about system logs, not the application logs. And here we have on a level 2, actually, we should have actually on level 3 that we will have the application login centralized once again. But for the first one, it's about the system login, and those are pretty much just that you need to have those logs available in a central place, and you don't need to start looking for your logs from different virtual machines or applications, trying to log into those machines and trying to combine them all together somehow by yourself. For the monitoring, you basically need to define simple metrics, those being the system metrics, budget metrics, and finally the application metrics. And they can be just how much CPU your application consumes, how much money do you pay for those virtual machines or web services that you use to host that application, and finally, how much for the application metrics, what kind of, for example, application metrics that you could use. That can be number of active users, number of active transactions, and so on. But those are from the application perspective and not the system perspective. So the difference between those are what you have from your infrastructure point of view and what is your application is doing. The next two, as you can see, they are grayed out, so easy to achieve, you have nothing to do. But the next one is a consolidation, and basically this means that based on your tests and feedback from your user, what you should focus on. And the first one is fixed based on severity. And if you have some sort of a high critical risk from the security point of view, then you need to focus on this one first before you continue with your development work from your business relevance. So in other words, if your application cannot be used at all, then you should focus on fixing the application rather than introducing new features. Simple false positive treatment. You should have tests covering your application, and if your tests are false positives, so they are saying everything is good, while it's not, you need to focus on that and fix those kind of issues as soon as possible, because it's much better to have a failing build rightly so, rather than a green build when everything is not actually secure. And basically, treatment of defects of severity high or higher, it means that those defects should have a priority, as I said. Next, our last two, let's quickly go through them. And the static depth for the infrastructure basically focuses on static tests, and in this case, on the static tests on the infrastructure. So it's not about the dynamic one, what is happening right now in reality. Instead, it is focuses on the static analysis of your infrastructure code, and that you don't need to hard code. In this case, you don't need to hard code or store the secrets anywhere, including your Git history. And for the test intensify, the last subdimension of the whole DSOM that we've made a whole circle, yay us, is about how you treat your tests. And the default test intensity, it basically means that you need to agree as a team that you want to have a certain level of test intensity. And if you would ask what is it, it's basically amount of tests and the code coverage of them, and how often do you run all of those tests. And the next one is that you want to have that high test intensity everywhere. With the default one, it means that you don't want to go back and disable some of the tests after you develop the feature. And the tests should be executed. You should execute all of the tests all of the time and have high standards for them. Wow, that was a lot to say the whole thing about that DSOMM model. But as I said, you can use the metrics and click on the title of each of the items to see some sort of a description about this. What is the risk that this thing tries to handle? What are the measures that you can take? And sometimes there would be an implementation guide on this. Additionally, there would be a metrics view of that same thing, and you can see that for the level one, you need to implement only those, and you can define, or at least I would suggest that you as a team would, if you want to implement the DSOM model, obviously, first of all, you would go through the whole thing and discuss it as a team, what you want to focus on, how you want to take this into your organization and into your work cycle. And after that, just if you're going to focus on DSOMM level one, create Jira tickets and focus on some individual ones that you don't have based on level one. And that can take a while, but it will be highly beneficial, I would say. So, getting back to the slides, we have just a couple of them left. The benefits of achieving level one, those are quite easy to get and understand, I would say, or I would hope, is that it creates a culture of shared responsibility for security. So everyone knows that your organization and you as a team of developers want to build a secure and highly very good product. And on top of that, it provides some sort of a foundation for scaling that security practices. So if you just start fast as some sort of a, I don't know, a startup, a single person startup, where you write something on your laptop and that's where your code lives and it works locally, then obviously you go next step and push your code into something like a GitHub. Uh, Public repository, and after that you might want to go into the real one. I mean, into the Azure DevOps project with multiple employees, and based on those DSOM levels, and DSOM level one in particular over here, it provides some sort of a foundation to scale those practices up and up more and more to have basically better protection against common vulnerabilities first, But as you go, your application would become more and more secure. Sometime you might want to actually stop with this implementation because your application might not need all of the security practices and be as secure as applications that, for example, manage nuclear plants. But obviously, situations and applications are different. So, as a last thing to wrap it up, what are the next steps after level one? Pretty much just to continue, as easy as it could be. So you already know what is your current posture, what is your current situation is a DSOMM level, and you might want to do a second workshop inside of your team or PMs included in terms of what are your plans for level 2 and what are your gaps according to level 2, and then to just continuously improve based on the feedback and evolving risks. I hope you will continue to do those risk assessments every now and then, at least a couple of times a year, and based on the new risks and new feedbacks, your backlog will be ever full, and there would be a lot of interesting features to focus on to work and improve your application as much as possible. And the most important thing, to keep on having fun during the development process. All right, see you in the next videos.